Good morning. Myself, C.D. Prem Kumar, Assistant Professor, Department of Information Technology, Hindustan College of Engineering and Technology, going to deliver a content on microcontroller and embedded systems. In this video, we are going to discuss the concept of characteristics and challenges of embedded systems. So here we are going to discuss two concepts. One is characteristics of embedded systems and challenges of embedded systems. So coming to the characteristics of embedded computing, we have 5 different characteristics. First one, complex algorithms, then user interface, third comes the real time, then multi-rate, finally cost. So we are going to discuss each and every characteristics one by one. So let's see one by one. The first one is under complex algorithms. So under this, the operations performed by the microprocessors may be very sophisticated. Example is the processor that controls an automobile engine must perform a very complicated filtering functions to optimize the performance of the car while minimizing some pollutions and fuel utilization. So coming to the user interface, processors are frequently used to control complex user interfaces that includes multiple menus and options. Example, moving maps and GPS navigation is the best example of sophisticated user interfaces. Most of the cars you have a GPS navigation, right? So that comes under the user interface. Next, coming to the real time. So many embedded computing systems have to perform in real time. That is, if the data is not ready by a certain deadline, the system breaks. In some cases, failure to meet a deadline is unsafe and can even endanger the lives. In other cases, missing a particular deadline doesn't create a safety problems, but it creates unhappy customers. Example is missed deadline in printers. For example, if the printer is not working properly, then the output, that is, you're going to, if you take important documents, it won't be a proper, the page gets scrambled, right? So you have to check before taking a certain documents. Coming to the multi-rate. So not only must operations be completed by deadlines, but the computing systems have several real-time activities going on at the same time. So control some operations that run at slow rates and other at high rates. Taking the multimedia applications, both audio and video proportions run at very different rates, but they remain closely synchronized. Then only you can able to see the video without any disturbances. So failure to meet a certain deadline spoils the perception of the entire presentation. So finally, coming to the cost, you have two different costs. One is the manufacturing cost, other one is the power and energy. Under the manufacturing cost, the total cost of building system is very important, mainly determined by the factors including the type of processor used, amount of memory required, and the types of input-output devices. Coming to the power and energy, the power consumption directly affects the cost of hardware. Then the energy consumption affects the battery life, which is important in most of the applications. So next comes the challenges of embedded systems. Under that, lot of questions arises. First is, how much hardware do we need? Then, how do we meet certain deadlines? Then, how do we minimize power consumption? Then, how do we design for upgradability? Finally, does it really work? We see each and every challenge one by one. Take the first one, how much hardware do we need? The great deal of the control over the amount of computing power we apply to most of our problems. So not only the processor used, but also we focus on the amount of memory and peripheral devices. So to meet both performance deadlines and the cost constraints, the choice of the hardware is very important. So if we take too little hardware and too much hardware, then we have to face the system failure, and also it becomes more expensive. Coming to the second challenge, how do we meet the deadlines? So in order to speed up the hardware so that the program runs faster. So it makes the system more expensive so that you will meet the deadline, but it's more expensive. So also it's possible that increasing the clock rates may not make enough difference to execution time since the speed may be limited by the memory systems. Then third challenge, how do we minimize the power consumption? The one way to make a system consume less power is to make run more slowly. But when you slow down, obviously you cannot meet the deadline. So in order to design a certain embedded system, you must go with a careful designing in order to consume the power. Then, how do we design for upgradability? Upgradation is a very important process here. So hardware platform may be used for over several product generations or for several different versions of a product in the same generation with few or no changes. So again, you can add some features by changing the software. Then finally, does it really work? So reliability is always a very important factor when selling some products. Customers rightly expect that products they build will work. So the sources that make the design so difficult are, we are going to see some functions. One is the complex testing. Under this, exercising an embedded system is generally more difficult than typing some data. So the timing is very important that we cannot separate the testing of the computer from the machine in which it is embedded. So coming to limited observability and controllability, embedded computing systems usually do not come with keyboards and screens. This makes it more difficult to see what is going on and whether it affects the system's operations or not. So we may be forced to watch the values of electrical signals on the processor bus, for example, to know what is going on inside a system. Moreover, in some real-time applications, we may not be able to easily stop the system to see what is going on inside. Best example is the washing machine. If you take the washing machine, you cannot stop the machine and see how the clothes are keeping washed, right? So it's the best example under the limited observability and controllability. Then coming to the restricted development environments. So the development environments for embedded systems are much more limited than those available for PCs and workstations. So generally we compile the codes on one machine and download it to the embedded systems. So to debug the code, we must rely on some programs that run on the PC, then look inside the embedded systems. So far we discussed the various characteristics of embedded systems and various challenges in embedded systems. Thank you.